Chapter 4, Part 2, Naming Alkyl Halides and Alcohols. First, before we move on to alkyl halides and alcohols, we have to talk about how carbon and hydrogen atoms are classified. So, these carbon and hydrogen atoms are classified by the number of carbons attached to the carbon you're describing. So, these carbon atoms are all considered primary because they only have a bond to one other carbon atom. So this is primary because it's attached to this one carbon. All these methyl groups are primary because they're only attached to one other carbon. These carbons in the middle are secondary carbon atoms because this carbon is only attached to two other carbons. Same with this one, two other carbons. If a carbon atom is attached to three other carbons, it's called tertiary. So 1, 2, 3. And if a carbon atom is attached to four other carbons, like this one, 1, 2, 3, 4, is called quaternary. So quaternary is spelled like this, and tertiary like so. And we use the same system to describe the hydrogen atoms on those carbon atoms. So this structure has all of the carbons and hydrogens drawn in. So on a primary carbon, the hydrogens are called primary hydrogens. There's secondary hydrogens, tertiary, and there's no such thing as a quaternary hydrogen because there are no hydrogens on that quaternary carbon. So why is this important? It's because when we're naming alkyl halides, we also describe them as primary, secondary, and tertiary. So you're going to name the halogen as a substituent using numbers to indicate the position on the parent chain, the same as you would with an alkyl substituent. So for example, this is chloroethane. You don't need to use a number because it can only be attached to carbon number 1. It's automatically number 1. For a propane chain, you have to indicate the number. So this would be 1-bromopropane because you can also have bromine on the second carbon, which would be called 2-bromopropane. Now the names that are in the parentheses underneath are the common naming scheme, and the top one is IPAC. So IPAC is going to be the preferred name. The common ones are there more for if you see those names, you'll know what they mean. So the IPAC structure is always to name it as haloalkane, where you sub in the prefix for the halogen, such as chloro or bromo. And the common naming is alkyl halide. So ethyl chloride, propyl bromide. If you have the bromine on the second carbon of a butane chain, you would call it 2-bromobutane, or you could call it sec-butyl bromide. But again, the IUPAC name is the preferred naming scheme. So just make sure that you read directions when you're given a quiz or test question. If it says explicitly IUPAC name, you should not use these names on the bottom. When a chain has both halogen and alkyl substituents, you still number from the end nearest the first substituent, whether it's alkyl or halogen. If you have two identical numbering schemes, you number based on alphabetical precedence. So halogens are not more important than alkyl groups when it comes to numbering. Oh, look, the same thing that I'd already said just popped up. So, okay, let's do these practice ones. Go ahead and pause and try to solve these yourself, and then we can work through it together. Okay, let's look at the first one. Our longest carbon chain is going to be 5 carbons, and we should number from left to right because the substituent will come up sooner that way. So 1, 2, 3, 4, 5. The correct name for this would be 2-chloro-3-methylpentane. Now let's look at our next one. We have a 5-carbon chain again, and our numbering schemes are actually identical. So if we started on the left, it'd be 1, 2, 3, 4, 5. Our substituents would be on 2 and 4. And if we started from the right, our substituents would still be on 2 and 4. So this is where that rule number 3 comes in. Now, what we're going to use is alphabetical precedence. So since chloro comes before methyl, or C before M, we're going to number left to right. So the name of this would be 2-chloro-4-methylpentane. Okay, let's take a look at the next one. The longest carbon chain is going to be 3 carbons long. And there are actually several 3-carbon chain possibilities, but you have to remember the rule of you want the numbering schemes that gives you the greatest number of substituents, and this one gives you 3 total substituents. So this is the best numbering scheme. We're going to start on the right-hand side. So we have a fluoro substituent. And remember that fluoro, even though it sounds like it's F-L-O-R-O, is F-L-U-O-R-O. And then we have 2 methyl groups on carbon number 2. So the name of this is 1-fluoro-2,2-dimethylpropane. This has a fun common name. This group here, including that CH2 group that the fluorine is attached to, is called neopentyl. And then we have one more. We have an iodine, and this one's kind of tricky. You can tell pretty easily that the common name for this is tert-butyl iodide, but trying to actually number it and come up with the longest chain is a little trickier. So what you actually have to realize is that there are a couple different 3-carbon chains that you could look at, and they're all identical. So you could say, okay, this is a 3-carbon chain, or this is a 3-carbon chain. It doesn't really matter. So 1, 2, 3. Both of your substituents are on carbon number 2. So it'd be 2-iodo-2-methylpropane, or tert-butyl iodide. While we're on this page, please take a look at the spelling of all the different halogen substituents. Iodo, fluoro, chloro, and bromo. This is the only place where you actually see all of them all at once. So this is a good time to, make flashcards if you're using that for substituent names, or just record them somewhere. So let's kind of summarize IPACs so far. The IPAC names are made up of 4 pieces. You have locants, which are the numbers indicating the locations of substituents and substitutions or functional groups. You have the names of your substituents, so all those prefixes. You have the parent chain prefix indicating the number of carbons in the longest chain. And then you also have something that we haven't really talked about, which is an infix and a suffix. So the infix is the part between the prefix and the suffix, which is actually just the letter E here. And this is important because we're about to switch that up. So the AN infix indicates that we have all single carbon-carbon bonds. The E suffix indicates that it's a hydrocarbon. So how to name alcohols. So this is all going to be very, very familiar, just with the small caveat of a hydroxyl group has a higher precedence than a halogen or an alkyl group. So when you're finding the longest continuous carbon chain, it has to be the longest chain that the hydroxyl is attached to, even if that's not the actual longest carbon chain in the molecule. And then you drop the suffix E and add all, OL. And you number the carbon atoms so that the hydroxyl group gets the lowest number possible. So even if that's not the overall lowest numbering scheme, you want the hydroxyl group to have the lowest possible number it can. So these rules haven't really changed. It's just now when you decide your longest chain in your numbering scheme, you have to be conscious of where the hydroxyl group is. And then you indicate the position of the hydroxyl group using that number. And you also need to list out your other substituents at the top of the name. So I think all these rules are much easier in practice. So we're going to go ahead and do the first row. Pause and try to solve it for yourself. And then I'll tell you to pause again so you can work on the second row. So pause. Okay, in this first molecule, we have the longest continuous chain is 3 carbons, and it's not branched or anything, so we don't have to worry about that. We want to number from right to left because that's the closest carbon to the hydroxyl group. And you also have to indicate which carbon the hydroxyl group is on because currently it's on carbon number 1, but you can also have a version of propanol where the hydroxyl group is on carbon number 2. So the name of this molecule is 1-propanol, often just called propyl alcohol. Now let's look at the next one. It's a 3-carbon chain. Again, you can number from left or right, it wouldn't matter. The only difference is that the hydroxyl group is on the 2nd carbon. So this is called 2-propanol, and it has a common name of isopropyl alcohol, which you most likely have in your bathroom or cabinet somewhere, or at least you should. Now the next one, our longest carbon chain is 4 carbons long, and it does matter which direction we number from. So we need to number from the left because that's going to be closest to our hydroxyl group. This molecule is 2-butanol, also known as sec-butyl alcohol. Okay, the next one is where we start throwing in some of these crazy new rules where we're worried about the alcohol more than anything. So we're going to number from right to left. So our family name here is going to be pentanol, and the hydroxyl group is on carbon number 1, and we also have a methyl group on carbon number 4. So the name of this molecule is 4-methyl 1-pentanol. Now you can also do something that we haven't yet seen, where you insert the number indicating the hydroxyl group in between the AN infix and the OL suffix. And you don't really need to do that for this molecule because the name 4-methyl 1-pentanol is very clear. But there are some situations where you start to have a lot of numbers inserted throughout the name. And so moving the number closer to the piece of the molecule that it's indicating can be a really good clarifying step. You'll start to see that more when we start looking at alkenes and as we get further into OChem. But just know that that means the same thing. Okay, go ahead and pause and work on the second row. Okay, let's name these. So, in this first one, remembering that we want to have the lowest number possible for the hydroxyl group, we're going to number from left to right. 1, 2, 3, 4, 5. So we have a pentanol here, and the hydroxyl group is on carbon number 2, and we have 2 methyl groups on carbon number 4. So we have to include quite a few pieces here. First, 2-pentanol is our overall parent chain, and we also have to remember that since we have 2 methyl groups, we need to use that di prefix. So the name for this would be 4,4-dimethyl 2-pentanol, or 4,4-dimethyl pentan 2-ol. Now in our next one, we have a bromo substituent and a hydroxyl group. Remember again that the hydroxyl group is the most important thing. So 1, 2, 3. This is going to be 3-bromo, 1-propanol. Okay, this next one is kind of tricky if you haven't been keeping up with your substituent names. So we have to number from left to right. 1, 2, 3, 4, 5. So we're going to have to indicate that this is a 1-pentanol. And we also have 2 different substituents. We have the phenyl group and the methyl group. And just remember that you have to alphabetize them. So the name for this is 3-methyl, 1-phenyl, 1-pentanol. Okay, now in the last one on the bottom, go ahead and take a second and think about it. What do you do when you have two of the same substituent? So we have 2 carbons, and the hydroxyl groups are on 2 different carbons. So this would be 1,2-ethane diol, or you could call it ethane 1,2-diol. Now, a lot of people want to call this like 1,2-diethanol. The issue with this is that the di is next to eth, which somehow indicates that you have multiple ethane groups. But what you're actually trying to indicate is that you have 2 alcohols, so that's why you say diol. So remember that the di prefix has to go directly next to what it's actually describing. The common name for this is ethylene glycol, which is one of the main ingredients of antifreeze.